Hi everyone, today we are going to study abstract factory design pattern. I've written the definition for it on the screen, and it is basically what abstract factory design pattern does is it provides us an interface for creating family of related objects. These objects could be related or dependent on each other as well. So an example could be, let's say we have our intelligent, there are themes in it, right? There's a dark theme, there's a light theme. A dark theme might have buttons, text box, menu bars, everything, and all of these are going to work together. These are simple products or objects, and on the other hand, the other theme, which is, let's say, a Dracula theme, that is going to again have different set of objects which work together. So that is a good example for abstract factory design pattern. Basically, we're going to get a interface created towards the end of that design pattern, and our client is going to use that interface, and we can inject different factories into our client. Basically, this can be slightly confusing from the outset, but then I'll go deep into the example step by step, how and when we need it. So it's also called a factory of factories. If you look at the second point, basically, again, this is something which I want to show once I implement it via an example, but for now, just do think it of as a factory of factories, sorry. Then if you look at the definition over the web for the abstract factory design pattern, you'll always come across these five things: abstract factory. These are the components in the design pattern. There are different interfaces or classes which are one of these category. There's a client, there's abstract factory, there are concrete factories, there are products, and there are abstract products. Rather than going into deep on these right now, I'm going to go and start to an example, and there I'm going to show you how we move to an abstract factory design pattern, how does the need arise, and then when we have the object class structure ready, then I'll show what is the abstract factory there, what is the product there, what's the abstract product there, what's the concrete factory, and what's the client. Let's go into the example quickly. Yeah, I've taken an example of payment system. Our client is going to be a payment service, and if you look at this diagram, it shows there's going to be a user which is going to interact with our API via, let's say we have our API payment service has a pay method, so a user is going to call that, and there's a payment gateway which is involved here, and then towards the right hand side you see bank APIs. So if you think about it, in real time, in real world systems, there are these payment gateway companies like Razorpay, Stripe, PayPal. What these do is they, on our application's behalf, interact to bank APIs. They send some request objects, they make the payments, and banks send the responses to them. So banks are not just our all the applications are not just allowed to directly interact with banks. There are payment gateway companies which sit in between, and that's where you see this flow. On the other hand, if you see at the responses from the bank, they go to the payment gateway. Then there's also a response from payment gateway to our payment service, and there's going to be an acknowledgement to a user or knack to a user. Just to clear here briefly, although it's not related to this design pattern, but this is a two-step process wherein once we go from user to this bank API via payment service via payment gateway, it doesn't directly send the response back. It is an async process, so payment gateway can take some time, and it is sort of our application is sort of listening to payment gateways continuously, and there's things called webhooks which help us to implement this system, this sort of design, and payment gateway always sort of asynchronously do the payment and return the responses to the payment service. That was not related to the video, but yeah, it's something which can be of good help in the future. So how would a payment service like above look like in a real world system? A junior developer or a layman guy would implement it straight away. They got the requirement, implement a payment service, they developed a payment service, and they were told Stripe is going to be our payment processor. Just implement it. The payment service, he created a payment processor which is actually going to make the payment process. This payment processor would be something like a REST call to it. This payment processor implementation might have API call to the Stripe interface, right? And let's say that is pay something. There's a different method inside it, but that's the job of Stripe's payment processor. That is responsible for interacting with the responsible for interacting with the Stripe. So our payments service interacts with Stripe via this Stripe payment processor for making payments. This is good enough design, but then there are flaws in it. People might come back, or clients, as they usually do. We have we want to onboard some other. We may onboard some other payment gateway in future, Razorpay. That would require a change in this class, but ideally that shouldn't be the case. We shouldn't code in such a manner that any change in our implementation of payment gateway requires a change in the payment service. That's not a good design. So a fix to this would be a quick enough, I guess. It can be you create an interface payment processor. This type payment processor is going to implement this interface, and inside our payment services, we use now payment processor interface rather than, so we have replaced this with the interface now. Sorry for that. Yeah, this was the interface which we created, and we sort of use this. Now a design becomes generic. In future, if Razorpay or any other implementation comes, we can create an implementation for it. That's a good enough approach, but then there are flaws to it as well. There might be a new requirement which comes into the party, and let's say our payment service also has to handle refunds. There's a different endpoint for refunds on the Stripe payment gateway. So what we decided is, well, let's add a refund processor as well. Now this refund processor can have multiple implementations similar to payment processor. We created a payment processor similar. This was the payment processor, and this was the payment processor, and now we created refund processor. Our services now have both payment processor here and refund processor, and payment processor is responsible for doing the payment here, and refund processor is responsible for calling the process refund method. This process refund for Stripe would call the for Stripe. Let's look at the implementation here. This is the Stripe's implementation, and this is the refund processor for Stripe. What we would do is have a REST call here which goes to the Stripe. It could be a REST call or any other mode of communication, but then this is the point wherein we do the refund processing, and it can be a separate endpoint. So this is a different class which we have created here. This is again a good design. We can sort of have another Razorpay's refund processor and Razor Stripe's Stripe's refund processor. This can go on and on. If you think about it, we have just got the refund part and the payment processor part covered. Say another requirement. We have to add something to handle the responses from the payment gateway. As I told you in the first part, payment gateway is going to send us the responses back to the payment service. So this is the interface for that. Bank is going to send Banks are going to send responses to payment gateway, and payment gateway are going to send responses to payment service. This is our client. So our service has to continuously listen to these responses. We have created a response handler interface for that. Now the response handler for Stripe is this. We have implemented this class here. This again is an interface. Our payment service looks very good here because all of them are interfaces right now. So we are coding as per abstractions, but there's something which we can now observe in the system. We are sort of building this parallel hierarchy of objects. Because we have to support Razorpay at the moment as well, we create another handle responsible for another handle Razorpay handle responser handler. So this is that class. What is this class basically? We're going to get responses from Stripe from Stripe gateway and from Razorpay gateway, and these responses can be different. For example, Stripe can send back a JSON response, whereas Razorpay sends still XML responses. So these classes have to be handled differently, and that's wherein we have created an interface and created two separate classes. But now if you think about it, this entire family of objects which we have here, this is Stripe related objects, right? About how our payment service interacts with Stripe, or how our payment service fetches responses from Stripe, or how our payment service do refunds via Stripe endpoint. And similar, there's a family of objects which is created here, which is Razorpay's implementation. These are related objects of Razorpay. These are again related Razorpay objects. We can see from the definition which we had defined, in that definition we had written interfaces, like abstract factory gives us an interface for creating family of related objects. Now these are the two families which we have right now. Forget the definition for once and let's do something. Now we know these all objects are going to be used together, stripes, and if we are using the Razorpay's implementation, all of the Razorpay objects are going to be used together. What I think we can do is probably introduce some classes. We have created a gateway factory. Yes, let's have a look at this. We have a gateway factory now, which is going to give us the objects of Stripe. So if you look at this Stripe gateway factory, this Stripe gateway factory creates Stripe payment processor, Stripe refund processor, Stripe response handler. We know that all of these objects are going to be used together, so we create a factory which is going to return its object here. Similarly, for the Razorpay gateway factory, we have created another factory class which is going to return the instances of Razorpay payment processor, Razorpay refund processor, Razorpay response handler. These are two different classes which we have created, and forget about this interface for now, but just look at the method signature here. Create payment processor method is going to return a payment processor. Create refund processor is going to return a refund processor. Create response handler is going to return a response handler. And if you look at it on the right hand side, for the Razorpay, it's kind of same story. Just the instances are different. But if you look at the parent method signature, payment processor create payment processor of this type also returns a payment processor generic type. So we have some sort of abstraction which we can see, which we can implement here. I noticed this and I created a gateway factory here. If you looked at this, this is the same interface, and this has the, as you would notice by now, this should have this signature: payment processor, refund processor, response handler. So if you go back to the definition right at the start, which I taught, it was abstract factory design pattern provides us an interface for creating, this is an interface, and it helps us in creating a family of object. This is one family, this is second family, and that's practically abstract factory design pattern in practice, how it looks. But let's talk about the client now. How would client change? Does it change in any way? We wanted to make our client better, right? The whole idea was to have our client that is going to be the best. What I did, I will first have a glance at the old this payment service. This is the old payment service. If you look at here, there are three three types of objects. These are products, payment processor, refund processor, response handler. These are all which were instantiated. So whenever payment service class was created, we would need to pass in new payment processor, new Stripe payment processor, and similarly new Stripe refund processor, new Stripe response handler. But then there could have been a problem wherein we passed in Stripe's payment processor but injected Razorpay's refund processor with it. Razorpay refund processor. This could have been done, which can be a problem, right? We don't want that. Hence, that is also a positive of the abstract factory design pattern which we have implemented. We are going to go away, we are going to sort of remove these from the constructor of the payment service, and now our payment service is going to look slightly different. And this now has an interface here, exactly the interface which we were talking right from the start of this lecture, the abstract factory interface. This is what we inject in our service. Now this factory is going to do a method call of create payment processor, create refund processor, create response handler. Again, now entire design becomes more generic if you think about it. Same, if I go towards the right hand side, these were my payment gateway factory implementation. This was Stripe gateway and this was Razorpay gateway. So now I have two implementation of payment gateway factories, and at the time of creation of payment service instance, we can inject any of those gateway factory in it, and that create payment processor is going to get called. That particular create refund processor is going to get called. That particular factory's create response handler is going to be called. So this sort of bundles all the related object creation in a single factory. And this is generic, so we can pass in different factories, hence the definition which we were saying, factory of factories. So there are factories, factory and payment gateway factory, and this is the main factory which helps us create it. Now if you look at the application code, our main application that is going to create, so I've done something here which many people might not like. I've used a if else here, so but then what I've done is this, I've created this factory kind of method. So what this does is, basis the gateway name, it's going to return a gateway factory. If gateway name is Stripe, it returns Stripe gateway factory. If gateway name is Razorpay, it returns Razorpay gateway factory. And whatever gateway factory we have created, those related objects get created and get injected in the payment service. Oops, sorry. Yeah, that's pretty much in from this method could have been better. We could have used switch cases and all enums for stripes and Razorpay, but I wanted to explain the major idea behind the abstract factory design.